All right, good morning. Welcome to the new unit, Unit 15. It's only 3 days of new stuff, a day of review, and a test next Friday. So a quick turnaround. It's not difficult. It just doesn't fill up any more than 3 days. Let's start, though, with some warm-ups. This is like super basic Algebra 1 warm-ups. With that lead up, we'll see how many people miss them. But find the slope between those 2 points. Do you remember how to find the slope?
Yes.
Slope is 3.
There we go. I heard it.
I got it before Andrew.
y2 minus y1 over x2 minus x1. So super basic stuff, but we need to do it today. So let's make sure we know how to do it. So do those 3 real quick, and then we'll go over them.
Okay.
So number 1's already up there. Again, this is easy stuff, but it's needed for today. 9 minus 3 over 4 minus 2. 6 over 2 is 3. Negative 3 minus 1. So this is just be careful with all the negative stuff. Negative 4 minus negative 2 would be negative 2. So that would be 2 for the final answer. And then negative 8 minus negative 5 over negative 3 minus 2. Just trying to throw all sorts of negative combinations at you to make sure you're paying attention. That would be negative 3 over negative 5 or 3/5. So not a big deal, but you'll need to know that for today. Today's notes are pretty short. And so we're going to do the thing where we take like 3 lines of notes at the top of the worksheet and then work some of the worksheet together. I assume no one will find that objectionable. You guys online, I've posted the worksheet packet for this week, so if you haven't, or this unit, so if you haven't already printed that out, grab that and we'll just take some notes on it and do some of the examples off of it. We can do it. All right, so this whole unit is about, like if you look at the very first instructions, find the slope of the line with inclination theta. So we've got slope, that's an algebra type thing. And we got theta, that's a trig type thing, angles. So this unit is kind of about the intersection of algebra and trig. Lines and angles. And it's really not even that complicated. Let's start with the line y equals 1/3 x. So intercept of 0, slope of up 1 over 3, slope of 1/3. The inclination is the angle from the horizontal. And from any horizontal. So normally we think of the x-axis as the horizontal, but any old horizontal would be it's going to be the same inclination wherever you draw a horizontal line. You can pick your favorite horizontal. Normally the x-axis is the easiest way to visualize it, but it doesn't really have to be the x-axis. Okay, the slope was up 1 over 3. So let's draw a little triangle in here. There's our angle. What's the opposite side of this triangle length? What's that side length?
1.
1. And how about this adjacent side length?
3.
3. So, 1 squared plus 3 squared would be 10. So that would be square root of 10. But we don't even need that. I mean, you're right, but it's not necessary today. The tangent of that angle. What's the tangent of that angle? Let's see, opposite over adjacent,
1/3.
or y over x,
1/3.
or 1/3. But what's another name for y over x?
Slope.
That's slope.
You can't see that.
So the tangent of the angle is equal to the slope. That's kind of the main thing we need today. The tangent of the angle is equal to the slope. And if we rearrange things, that means the slope is equal to, whoops, that's not how I want to do that. That means the angle is the inverse tangent of m. But that's kind of the same thing, so I don't even know that I would box the second one. That's the same equation, just rearrange. Now, there's some more complicated equations we'll get to in a minute, but we'll give you those when you need them. I mean, it's open notes, so we'll give you all of them. But normally, this is the only thing you have to memorize for this unit. So let's do basically we're going to work through the evens, and I'll leave the odds for you to do. So find the slope of the line with this inclination. Well, slope is equal to tangent of theta. Slope is equal to tangent of 3 pi over 4. Oh, unit circle.
Oh no.
Oh, yes.
Good thing it's open.
Let's see, 3 pi over 4. A quick word on the open note thing. Obviously, it's continuing to be open note because our friends at home, it's nearly impossible to monitor what they're using. I hope you know the unit circle. If you still are looking up everything on the unit circle, then next year is just going to be awful when we go back to not being open note and you've got to know stuff. So, I mean, I know that puts responsibility on you, but if you're just, skating by every time, relying heavily on notes, then it's going to fall apart for you next year. So that's a warning, but also, get ready and make sure you know the unit circle and know what you're supposed to know for next year. All right, 3 pi over 4, that would be right there. So the tangent of 3 pi over 4. What's the tangent of 3 pi over 4? Y over x. And that's the whole point, right? Slope, y over x. They're equal to each other, but it's going down, or the x is backwards. So -1. Because the tangent of 3 pi over 4 is -1. Right? If theta equals 2 pi over 3, then the slope is tangent of 2 pi over 3. So, without looking at a unit circle, why don't you see if you can figure out what the tangent of 2 pi over 3 is? What's the 3 rule? You're on the right track. If it's 3, if there's a 3 in the bottom,
One with the highest.
well, yes, it is a steep angle. Yep.
That makes it. No.
And the 3 trick, so all the tangents are either 1, square root of 3, or root 3 over 3. But the 3 trick is, if it's over 3, that means there's only 1 3 in the answer. Square root of 3. Now, is it positive or negative?
Negative.
In the second quadrant, it would be negative. Or, yeah, you could get the slope from just doing what you normally think of as slope. If it's, as you move left to right, if you're going down, then the slope's negative. So, yeah, you can know the slope without knowing or you can get the sign from the slope rather than from the tangent. But either way, it's negative. Either way.
Mr. Wolf,
Yes, sir.
what's the point of drawing the picture?
You don't need to draw the picture. I draw the picture because it helps me think through, helps my brain think through what's going on. But if you know what tangent of 2 pi over 3 is, you don't need to draw the picture.
I was one of the kids who didn't use my unit circle on the test.
Number 6. Find theta if you know m. So this is sort of the backwards problem. So 1 equals tangent of theta, which means theta equals inverse tangent of 1. So you can probably get this one without a picture, I hope. What angle has a tangent of 1? You took it like one step too far. It's not root 2 over 2, although root 2 over 2 is involved with this angle. Pi over 4. And at pi over 4, sine and cosine are root 2 over 2. So that's where your brain was going.
But your brain was wrong.
It wasn't. I had the right answer.
Number 8, negative 5 halves equals tangent of theta. Good, that one's not on the unit circle, is exactly right. So I will need a calculator for that one, because that is not on the unit circle. Yeah, if you know this one, I'll be impressed. We're back to radians, so make sure you're in radians, especially since you were in degrees yesterday. Yeah, most of you are probably still in degrees. I mean, you might have gone to physics, but physics would be in degrees too. So switch to radians. Inverse tangent is probably going to be a weird number because it's not on the unit circle. Negative 1.19. Number 10. Find the angle in radians passing through the points.
No, you just gotta find the slope, dude.
So, what do we got to do,
Find
dude?
the slope.
We got to find the slope, dude. That's correct. So, y2 minus y1 over x2 minus x1. Negative signs all over the place, but you're more than capable of handling that.
Okay, we got it, guys. Yep, so it's radical 3 over 3.
So it is radical 3 over 3
Negative.
with the negative on there. So that's what the slope is equal to. So what angle has a tangent of root 3 over 3?
6.
Something over 6 for sure. That's the tangent 3 trick.
5 pi over 6?
I think I agree.
Yeah, because it's negative.
Yes, 5 pi over 6.
So it's negative, so you could think of it as doing that.
Or it could be the other one, 11 pi over 6. Negative.
Let's go with negative pi over 6. So all three are kind of right. 5 pi over 6 is this way. 11 pi over 6 is this way. But if you remember when we were dealing with tangents, we'd really rather go the shortest way possible. So let's go with negative pi over 6.
I got it right.
I was closer to the right answer.
Sounds like, yeah.
I'm the one that said it, so.
Why is it not?
Because it's not as close.
Because you're wrong. No, positive numbers are easier.
Because if you're just thinking what's the angle of that line, you probably wouldn't say it's 5 pi over 6. You'd probably just say it's negative pi over 6, which is down a little bit.
It's just like.
Down, negative a little bit.
We're a little late.
All right, why don't you try number 12? I don't think that's going to be on the unit circle, so you'll need a calculator for that one.
That doesn't stop me. I'm kind of like that.
All right, since you're going to the calculator, you don't really even need to reduce that. Right? I mean, you could, because it would be negative 5 over 3, but it doesn't matter because you're going to type it in the calculator anyway. So inverse tangent, negative 20 over 12, negative 1.03.
How many decimal points do we go over?
It doesn't say, so 2 or 3.
Okay.
Good question on the decimal point there. All right, flip it over to the back.
Yo, what is this? I'm not gonna get all of that.
All right, find the angle in radians between the lines. So now I got two lines. They presumably intersect somewhere, and I'd like to know the angle between them. Well, there's two ways to do it. You can go the long way and find the angle of each one, and then like try to figure out, do I add them or do I subtract them, or how does that work? But if you look down at the bottom, we should have put it at the top. There's the cheat code down there. That's for the angle between two lines. There's another cheat code down there that we'll talk in a minute. It is distance. That's what the D stands for. So tangent theta equals absolute value m2 minus m1 over 1 plus m2 m1. So I need to find the two m's, and then I'll be ready to use this equation. How do I get an m out of number 14? How do I get m out of that first equation? What do I need to do?
You subtract the x and then turn all the signs.
So a couple ways to do it. I could subtract the x over, and then I could divide by negative 2. Okay, how's that help me? What's the slope now? 3/2. Good. You remember your Algebra 1 days. And how about the other one? Let's see, that's just y equals x. So what's the slope of that line? 1, right? To grab the coefficient of x. Now this whole thing is in absolute value, so that really means it doesn't matter which one we subtract. So I think I'll just put the 3/2 first. In fact, it might be best to just put it in the calculator, because I want to do inverse tangent of all that. Okay, so how do I absolute value? So inverse tangent. I believe it is math to find the absolute value. And then scroll over to num for like numbers. And abs. It's not talking about doing sit-ups all day long or planks. It's talking about absolute value. And if you have the latest operating system on your calculator, which this one doesn't.
Oh, that one's the bad one.
That's the bad one. But we can compare here. So that would still work, but I don't want to work with abs. I'd rather work with the bars. So I got an old calculator and a new calculator up here. Thank you very much. I'll use the new one. Okay, so inverse tangent, math, and then num for abs. And then either, I think maybe a fraction bar. We'll just make this look exactly like our paper here. So 3/2 minus 1. I guess you could have gone a fraction within a fraction, but come on, it's just 3/2. We can handle this. Over 1 plus 3/2. Whoops, I grabbed a different calculator, so I need to switch back to radians. You're right, that's not very big, but that makes sense. A slope of 1 and a slope of 1.5. That's pretty close to each other. And hold on, that's not right, because I need to switch it to radians.
Okay, I got confused.
But most people think in degrees better. So 11 degrees makes sense for a line that has a slope of 1 and a slope of 1/2. Those would be pretty close to each other. So you can do a little bit of a check on them to make sure they make sense. All right, 16, 18, 20. Find the distance between the point and the line. This is the other cheat code down here.
Yeah, what's the policy on that?
If I give you the equation, it's not cheating. It's using what you need to know.
Okay.
distance between the point, x1, y1, and the line, although we do need to be a little bit careful because our line needs to look like this equation for a line, which we don't use very often. ax plus by plus c equals 0. I think standard form or general form is the name of that. Usually we prefer slope-intercept, but for this problem we need it to be in standard form. So let's do number 16. So I've got the point, I've got the line, but it's not in standard form. I just need to make it equal 0. So I'll subtract the y over and put things in the right order, x, y, number.
Wait,
Should we always put it in x1 number?
does it matter which one follows it?
It doesn't matter. So if you wrote this kind of differently, if you move things to the other side and have negative 2x plus y plus 1 equals 0, that's the same thing. And if you look at the formula, it has absolute value bars on it, so if you missed the sign up, well, you didn't mess it up. It doesn't matter. You're going to be okay either way. So I like the first one, so I'm going to use it. So absolute value of 2, but n for x is going to go 3, minus y, n for y goes 2, minus 1, all over the square root of a squared plus b squared. You know what? I wonder if it would have been better if we had just labeled them to begin with.
Oh, yeah, that might be
I'm going to mark this one out, otherwise I'm going to get confused. Not that it was wrong, it's just I need to pick one. So what am I using for A? 2. And what's B? Negative 1. And C? Negative 1. So square root of a squared plus b squared. And now you can just put that in the calculator. That's a lot of typing, so if you have a little bit of math sense to you, it might be easier to not use the calculator. 6 minus 2 minus 1 would be 3 over the square root of 4 plus 1 is 5. So I would say, for some of you, it's probably easier to not use the calculator. If you're going to use the calculator, you better get all those parentheses correct, squaring negative numbers, all those little things that mess people up. Be careful about. Oh, you know what? If you use the calculator, you'll get a decimal, and that's okay too. So let me see what the 3 root 5 divided by 5. 1.342.
That's what I got.
So either one of those answers would be okay, because you could use the calculator or not. Either way. All right, why don't you try 18? There's a lot of steps going on in there, so you try 18.
Oh, I messed up.
So there's a little bit of a midpoint check up there, see how you're going. Keep going, and we'll see if you get the final answer. I made a mistake. He's correcting me. That's what I want you to do.
not with the attitude.
Not with the attitude that he was given.
It's not okay.
Looking for my whiteout. Oh, here it is. Because then it looks so much better. Although I'm recording, so everyone will know that I'm not perfect.
That Andrew has attitude?
I think everyone already knew that. So yes, let's change the, let's put the correct number in the right spot. I even tried to color code it for myself and messed it up.
It's okay. Don't be too hard on yourself.
So, try that. Let's see. 2 plus 3. Uh-oh. Something funny's going on this one.
It's 0.
It is 0. 2 plus 3 is 5. 5 minus 5 is 0. And then it doesn't really matter what the bottom is. So what does that mean if the distance from a point to a line is 0?
The point is on the line.
Yeah, so I mean my answer is still 0, but to make sense of this problem, that means the point is on the line. So that's kind of a weird one. No, not question mark, just exclamation point. You don't have to say that, but that might help make sense of that problem. Like, what is going on here? Well, if the point is on the line, then yeah, the distance from the point to the line is 0. Alright, so several new equations today, but you'll have them all. They're pretty straightforward. You got a calculator. Not too bad. So your assignment is the rest of them. We did almost half of them. Most of you have already done some of the others anyway.